This is screencast number 3 for Professor Morrison's Physics 101 class. The question was to watch a video that was posted on the Angel site and find the velocity of the ball right after the first bounce off of the stage floor. We were given in the video the distance between two poles, which was 2.7 meters. We could deduce the time of the ball's bounce in the x direction from when it would be between the two posts and the y direction from when it would hit the bottom of the stage. The acceleration in the x direction is 0, and the acceleration in the y direction would be negative 9.8, because the ball is in midair. I found that the distance in the y direction is equal to 0 at the final and the initial of the bounce. Well, the unknowns would be for the equation would be time and velocity initial. To find the velocity initial, since the acceleration in the x direction is 0, would use y equals y naught plus v initial times time plus a half of the acceleration in the y direction times time squared. The free body diagram shows that the only force working on the ball at this time would be gravity. The starting frame for the bounce in the x direction is 16, and the finish is 36. By finding the difference, we get to 20 frames. Divided by the 30 frames per second would come to 0.007 time for seconds in the x direction. However, to find it in the y direction, the start is 5, and the finish is 43, making 38 as the difference. 38 divided by 30 would come to 1.267 seconds in the y direction. The two vectors are up, and the up direction is 6.2, and going to the right in 4.05 meters. By drawing the two together and find the vectors and the magnitude, I simply took the tangent, which is opposite or adjacent, used the Pythagorean theorem to find that cu equals 7.41 meters per second up in the right direction. By taking the inverse of the tangent, I also found that it was 56 degrees up. I was also able to take all of these to solve the equation. Plugging everything in, I found that the initial velocity in the y direction was 6.2 meters per second up.